We tend to think of AI as these super powerful, almost flawless minds. But what happens when they break? And I don't mean just giving a wrong answer or showing an error message. I mean, what happens when they actually, truly lose their minds? Well, let's take a look at the evidence. This right here, this is the sound of an AI completely falling apart. This string of absolute nonsense came from Llama 3.2, a really sophisticated model with over 1 billion parameters. This isn't just a mistake, it's total gibberish. You should think of this as our crime scene. Something inside the AI's digital brain went catastrophically wrong to produce this. So that's our big mystery today. What could possibly cause the system that's been trained on basically the entire internet to suddenly start spouting pure chaos? For this explainer, you and we're going to be detectives. We're going to follow the clues from some amazing research to figure out exactly what causes an AI to snap. Now, to solve any mystery, you've got to understand the victim, right? So first, we need to take a look inside the AI's brain to understand how it's even put together. Once we do that, we can start to figure out where the weak spots might be hiding. Our lead detectives on this case are a team of researchers from King Mongkut's Institute of Technology in Thailand, and their subject is a pretty popular open-source model, Llama 3.2. Now, that one B in its name means it has over 1 billion parameters, which you can just think of as 1 billion tiny pieces of knowledge all stored away in its memory. So how does an AI actually think? Well, it's built in layers, kind of like a cake. This particular model has about 16 of them, and each layer is like one step in its thought process. And in every single step, the AI does 2 main things. First, there's self-attention. That's where it figures out which words in a sentence are the most important ones to pay attention to. And second, there's a feed-forward network. That's where it actually processes all that info and thinks about what it's going to say next. So if you want to find a weak spot in a digital brain, what do? Well, you stress test it. You push it until it breaks. The researchers figured the best way to understand why an AI fails was to break it themselves, very carefully and very much on purpose. The technique they used is called parameter corruption, and you can basically think of it as targeted digital amnesia. The researchers literally go into the AI's memory, all those billions of parameters, and start setting them to 0. They're effectively erasing tiny little pieces of its knowledge, one by one. Their plan was so simple, it was brilliant. Step 1, start with a perfectly healthy AI and ask it some questions to see what a good answer looks like. That's your baseline. Step 2, start breaking it. Corrupt a small percentage of its parameters. And step 3, ask it the exact same questions again and see how much worse the answers have become. So the researchers started turning up the heat. They slowly increased the damage, little by little. They were looking for that exact moment, that tipping point, where the model goes from being just a little bit wrong to being completely incoherent. And this graph shows exactly what they found. It's fascinating. See, all those colored lines measure how good the AI's answers are. Higher is better. As you move along the bottom, the corruption gets worse. And you can see the lines hold pretty steady for a while, and then, boom, they just fall off a cliff. The AI's performance doesn't just get a little worse, it completely collapses. And what was that tipping point, the point of no return? Turns out it's this number, 15%. The second the researchers damaged just 15% of the AI's total memory, its ability to think straight just shattered. And that's what leads to the kind of breakdown we saw at the very beginning. This table really shows you what that mental breakdown looks like in practice. When you ask it what is the capital of Thailand, a healthy AI gives you the right answer, Bangkok. With 5% damage, it's still fine. But look at 15%. It's already starting to lose the plot, right? It's not answering the question anymore. By 40%, it's just spouting nonsense about highways. And at 100% corruption, well, it can only repeat the word heirs over and over again. It's a complete system failure. Okay, so we know that AI breaks down right around 15% damage. But that just leads to an even more interesting question. Is all damage created equal? Or are some parts of the AI's brain way more fragile than others? The investigation was not over yet. So the next logical step was to get more specific. What if they only damaged the self-attention parts we talked about? Or what if they only damaged the feed-forward parts? Would one of them turn out to be the real weak link? And this slide right here, this is the smoking gun. Remember, higher lines mean the AI is doing better. Now, look at the graph on the left. That's when they only damage the self-attention parts. The lines go down, sure, but it's a pretty gentle slope. The AI gets worse, but it doesn't totally break. Now, look at the graph on the right. When they damage the feed-forward networks, wow, the performance doesn't just drop, it absolutely craters. That is the catastrophic failure we've been hunting for. And there you have it. The mystery is solved. The feed-forward network, that's the part in each layer that's supposed to process information and figure out what to say next, is the AI's Achilles heel. It is way, way more sensitive to damage than any other part of its brain. They even narrowed it down to the single most fragile component of all. It's a specific part inside the network called the FF down matrix. And why is it so weak? Because it's the very last step in each layer's thought process. Damaging it is like sabotaging the final quality check on an assembly line. It just ruins the entire product. They also discovered that the later layers in the AI's brain were much more important than the earlier ones. So who cares? Why does any of this actually matter? I mean, why would you spend all this time and energy figuring out how to break an AI? Well, it's simple. If we can understand exactly how these things fail, we can finally learn how to build them so they don't. So let's wrap up our investigation. What did we find? First, an AI's mind isn't some magical, unbreakable box. It has very specific weak spots. Second, when it fails, it doesn't fail gracefully. It falls off a cliff. And third, and most importantly, we found the weakest link in the whole chain, the feed-forward network, the part that's essential for coherent thought. And this, right here, is the real payoff. By learning exactly how to break an AI, we can finally learn how to build a better one. This research is basically a blueprint for creating fault-tolerant AI. So, imagine a chip for a self-driving car. Now that engineers know the FF down matrix is a major weak spot, they can design the chip to protect it, maybe by building in a backup system, or even physically placing that part of the chip in a safer spot. And all of this leaves us with one last big thought. As AI gets woven into the most critical parts of our world, our cars, our hospitals, our banks, we simply can't afford for it to have a sudden mental breakdown. Understanding its fragility isn't just a cool science experiment, it is the absolute first step toward building AI that we can actually, truly trust.